Hello class. Today we're going to talk about topic 7-5, which is 45, 45, 90 triangles. These are special triangles that will follow special rules as far as figuring out the sides. Now, we can use Pythagorean theorem, or we can just follow these simple rules. So if I have a 45, 45, 90 triangle, that means that it's isosceles, which means that these two sides are in fact the same. And this side would be x on the square root of 2. So, just let me go ahead and work this out real quick so we can prove it. X squared plus x squared equals my hypotenuse. So this makes 2x squared equals my hypotenuse squared. If I divide, okay, and then I want to figure out what my hypotenuse is, so I take the square root of both sides. So what I have here is 2 times x equals c. And all that's under a square root. Well, I've got a pair of x's, so that's going to come out, leaving me x on the square root of 2 equals c, which is here. Now, all of this work over here is work that you don't actually need to worry about. This just proves that, hey, if I have a 45, 45, 90, where this is x and this is x, then this will be x on the square root of 2. Alright? So, let's go ahead and look at what our labels are going to be, just so we can get practice labeling these. A, B, and C, this is going to be x on the square root of 2. So AB was x, BC was x, and AC is x on the square root of 2. Example number 2, my legs are x's, my hypotenuse is x on the square root of 2. So AB is x, BC this time is x on the square root of 2, and AC would be x. One more example like this, if we have number 3, my two legs are x's because these are 45-degree angles. This would be x on the square root of 2. So AB this time is x on the square root of 2. BC is x, and AC is also x. So this is just labeling our triangles. We haven't really figured out what the lengths of any of these sides are. This is just getting practice labeling. The hypotenuse is the x on the square root of 2. So that will let you know which one it is. Let's go ahead and look at the next page and get some examples of where this is actually useful. So for example number 4, we're given that this is 5, which means that this leg is also 5 because they're the same, which means that our hypotenuse is 5 on the square root of 2. I've just replaced x with the number 5. So AB is 5, and AC is 5 on the square root of 2. Now, if we were looking for a number that we could use, I might put this into the calculator and come up with something that it's close to. But since we're not dealing with any type of units or type of word problem, I'm going to leave this as a square root because that's the most accurate way to have this answered. I'm going to look at example number 5. Well, here we have x, and x on the square root of 2. And we see this is 4 on the square root of 2, which means that x must be 4. That means this side is 4. and this side is 4. So AB is 4, and BC is also 4. So examples 4 and 5, those were the easy examples. Those were the ones where there wasn't a whole lot of thought. You can just spit out answers. However, example number 6 is slightly more complicated, because if I label this as x, x, and x on the square root of 2, I don't automatically know what x is. I know that 6 equals x on the square root of 2. It doesn't equal x. So I need to figure out what x is. So to do this, I'm going to simply divide both sides by the square root of 2. That gets rid of my square roots of 2. So now that x equals 6 over the square root of 2. Problem is that I can't have a square root in the bottom. So I'm going to take my 6 over the square root of 2. I'm going to multiply it by a fancy version of 1, the square root of 2 over the square root of 2. What that's going to do is that's going to give me 6 on the square root of 2 over 2. Because the square root of 2 times the square root of 2 equals a regular 2. And well, 6 over 2 equals 3. So this is 3 on the square root of 2. Now, there's a shorter way of doing this. If I divide by the square root of 2, I can take my 6, divide by 2, and then multiply by the square root of 2. So 6 over 2 times the square root of 2 is 3 on the square root of 2. And this is the easiest way to divide by the square root of 2. It's to divide by 2, then multiply by the square root of 2. So we know that this is 3 square root of 2, and this is 3 square root of 2. So AB is 3 square root of 2, and BC is 3 square root of 2. Let's go ahead and take a look at another example. This is our last example. We're talking about number 7. Well, we have x, x, and x on the square root of 2. Well, if this is 2 on the square root of 3, that means this is also 2 on the square root of 3. Now, I need to figure out what this side is. Well, it's going to be 2 on the square root of 3 times the square root of 2. Now, if you're not familiar with multiplying involving radicals, here's how you do it. You multiply the outsides, then you multiply the insides. Well, 2 times 1 is 2. And 3 times 2 makes 6. And the square root of 6 doesn't simplify, so I know that this is 2 on the square root of 6. Let's go and look what we have. AC, that is 2 on the square root of 6. And BC, that is 2 on the square root of 3. So, this is how you use 45, 45, 90 triangles. The math becomes much easier. We're not actually worrying about Pythagorean theorem anymore. All we're doing is we're finding what the sides are by either multiplying or dividing by the square root of 2. So, again, you may want to rewatch some of these to understand what's going on, especially paying attention to examples number 6 and examples number 7. But have a good afternoon, and good luck on your assignment.